These are notes introducing writing electron configuration, and what we're going to do is use this blank periodic table and give an overview of what we want to do when we're reading electron configuration, and a little bit of why we do electron configuration the way that we do. So what is electron configuration? And in brief, it really just helps us predict where electrons are located around the nucleus. And we're going to get into further definitions and further reasons why we have electron configuration as we go through our notes in the atoms unit. But just a brief overview of electron configuration is that it helps us locate those electrons. So we've got sections of the periodic table that we're going to talk about and identify, and we're going to call these orbitals. And those orbitals are going to go with those sections on the periodic table. And we're going to go further into what exactly these are also when we get a little bit deeper into our PowerPoint notes. One thing that we want to make sure that we understand is helium, while it is a noble gas, so is listed over here on the periodic table, is actually going to be over here for our sake of writing electron configuration at the beginning, simply so that we can remember that it's in row 1. So we're going to label our rows 1 through 7. And then we're also going to label those sections of the periodic table that I referenced right up here. And these are called orbitals. So our orbitals are the S block right here. And this is another reason why we moved helium over, is because we want to remember that helium is in the S block. So the S block are the first 2 columns. The D block are our transition metals. So they're right here. There are 10 columns in the D block. The P block is right here. There are 6 columns in the P block, 6 groups I should say, in the P block, and then our F block is 14 across, and our F block is our inner transition metals. All of these have different shapes to them. Again, we'll learn that as we get further into the PowerPoint notes. So how do we read the periodic table when we're looking at electron configuration? So we're going to read the periodic table like a book. We're going to read it left to right. So just like we would read a textbook, we're going to go left to right, and that's how we're going to identify our electron configuration sections. So the first thing that we want to identify with electron configuration is the row. So again, we've got rows 1 through 7. The second thing we're going to identify is the orbital that we're in, or the block that we're in. So if we're in the S block, the D block, the P block, or the F block. And then the third thing that we're going to identify is how many over in that block, how many spots over in that block that we have gone on the periodic table, or how many we have to go. So for example, the S block, we're only going to ever go 2 over with the S block. The D block, we could go 10 over. The P block, we could go 6 over. And the F block, we could go 14 over. So I'm just going to relabel this for the sake of having some room to talk to you. So we're going to have our rows in there. And so let's write out an electron configuration sentence here. So the first thing that we're going to do is identify our row. So I've highlighted it right here, so we're in row 1. And then the second thing we write is the orbital. So the S block, we're going to say 1s. And then the next thing that we identify is how many over in that block we've gone. And so our electron configuration for hydrogen would be 1s1. So the 1 tells us the row, the S tells us the block, and the superscript 1 tells us how many over in the column we've gone, how many over in the block we have gone. And the S also tells us not only the orbital on the periodic table, but it also tells us the possible area around the nucleus that electron is orbiting. Those S, P, D, and F orbitals are all different shapes, and we're going to get into that and those shapes once we get to the PowerPoint notes. That little superscript 1, it's written as a superscript, it's really important, and it just tells us how many electrons are present in that current electron configuration. So that's the electron configuration for hydrogen. So let's practice for helium. So we're going to do the same thing. The first thing that we identify is the row. So we're going to identify that it's in row 1. Then we're going to identify that it's in block S. And then we're going to look and see how many over do we have to go. So because we don't have to hit hydrogen, we're not actually going to write 1s1 and then 1s2. All we have to do is say, okay, I'm in row 1, I go over 2, and I've hit helium, so then I say the superscript 2. So again, I'm going to identify the row, I'm going to identify the orbital or the block on the periodic table, and then I'm going to identify how many electrons are present in the block, and how many in the orbital and in the block, and again how many over I needed to go in that block to identify it. So the electron configuration for helium is 1s2. So let's get some more practice. Again, just relabeling my blank periodic table so you can see my notes here. So we're going to practice sulfur. So sulfur is right over here. So we're going to say, we got our rows labeled, and that helps us figure out where we're going. So we're going to say 1s2. So once we hit our row, we're going to go on to the next row. So what I kind of like to say is, I'm in my row 1, I know I'm in block S, and I've gone 2 over in that block, and I have not hit sulfur yet. So I'm going to write down 1s2 as the beginning part of my electron configuration. Because I haven't hit sulfur yet, I'm going to move on to the next row. So now I'm going to move on to 2s, and I've gone 2 over in the S block, and I still haven't hit sulfur. And so that's why I'm going to write the 2s2 right there. So then I go, at the end of that, I now know that I'm still in row 2, so I have to go over to the next block that's also row 2. So that's the P block. So then I'm going to say 2, because I'm still in row 2, and I've moved to a new block. So I identify the block, and I've gone all the way over in the P block without hitting sulfur. So I've gone 6 over, and so now I have to say 2p6 as the next step in my electron configuration. I'm going to move on to the third row, because again I still haven't figured out, I still haven't gotten right to sulfur. So again, because we didn't reach sulfur, we've got to move on to the third row. So I'm going to say 3, because that's what row I'm in. I'm going to say S, because that's the block on the periodic table I'm in. And because I've gone 2 over in the S block and I still haven't hit sulfur, I'm going to identify that with a superscript of 2. Then I finally go to the P block. So I go 3, P, and I've reached sulfur, and it only took me 4 over to get to reach sulfur. So 3p4 would be my electron configuration. So the whole electron configuration for sulfur would be 1s2, 2s2, 2p6, 3s2, 3p4. So again, the 3 tells us the row, the P tells us the shape predicted around the nucleus that electron is most likely going to be in, and the 4 tells us how many electrons are in that orbital. So just a couple more notes here as we go. We're going to have to look at talking about the D block and the F block. So the D block, the rule is to take the row and subtract it by 1. And the reason why we do that is because our valence electrons, we can only have 8 valence electrons. And we'll get into that a little bit further when we talk in the notes. So let's look at cobalt. So cobalt, as we start, is going to be 1s2. And then as we go further into the row, it would be 2s2, as you're following the highlight along that periodic table example. 2p6, and we went all the way to the 6 because we hadn't reached cobalt yet. 3s2, 3p6, 4s2. Now here's where we have to take into account, because now we're reaching the D block, and so because our D block rule is to take the row and subtract by 1, I then have to say 3d7 because I went over 7 in the D block. And so again, why is because we can only fit 8 valence electrons in the outer shell, and so the electrons in the D block and the F block jump back into the shells above it. And I know if that's a little bit confusing right now, that's okay. We'll talk further about it in class when we get into those PowerPoint notes. But we just need to remember that that rule is 3d7. So the F rule is that it's the row minus 2. So we won't use the F block very often, but when we get to the F, for example, if we were saying like row 6, it would be 4F14, for example, if I were to go all the way over. So the D and the F block have specific rules that we need to make sure that we remember. All right, so there's an introduction into how to write electron configuration. Hopefully, if you have some questions, you can write those down and come to class the next time that we meet with those specific questions. And hopefully that just gives you a good introduction in terms of what we do when we write electron configurations. All right, thank you.